Number 68, solve the following logarithmic simultaneous equations, or solve the following simultaneous logarithmic equation. The first one, log y minus 1 to base 2 is equals to 1 plus log x to base 2. Second one, 2 log y to base 3 is equals to 2 plus log x to base 3. So let us start with the first one. The first one we have log y minus 1 to base 2 is equals to 1 plus log x to base 2. Now here, for us to go to a point of ignoring the logs, we must have the same base throughout in each and every term, isn't it? So here is to base 2, meaning this one must have log to base 2. So we introduce log 2 to base 2, because a log of a number with the same base is 1. So we have base 2, base 2, base 2 throughout, isn't it? Are we together? See, the next step is now to get rid of the coefficient, meaning this one becomes the power, isn't it? Are we together? So either side of the equation we must have one term. So here we have log to base 2 of y minus 1. The other side, if you factorize out log to base 2, addition will be multiplication, isn't it? 2 raised to power 1 is just 2. So 2 times x, you get 2x. So that when you take log to base 2 inside the bracket, this multiplication goes back to addition. Are we together? So if you have a single term on the other side of the equation, you can now ignore the log, so that you remain with y minus 1 is equals to 2x. If you take 1 the other side, you see y is 2x plus 1. So we found the first equation, y is equals to 2x plus 1. Then we use the second one to get the second equation. Are we together? Good. Go to the second one. We want the second equation. The second one, you have 2 log y to base 3 is equals to 2 plus log x to base 3. We must have the same base throughout, isn't it? So here we have 2 log y to base 3 is equals to 2, meaning we introduce log 3 to base 3, which is 1, isn't it? So we now have the same base. Then there we have log x to base 3. So we have each and every term is having log to base 3. That is why we introduce log 3 to base 3, which is 1. Are we together? Then you get rid of the coefficients. So you start, this coefficient becomes the power, so you get log y squared to base 3 is equals to, this coefficient becomes the power, you get log 3 squared to base 3 plus log x to base 3. Are we together? Okay? So this is log y squared to base 3 is equals to log 3 squared is 9, isn't it? To base 3, then plus log x to base 3. So the next thing is to ensure you have one term on either side of the equation. This side is already one term. We have log to base 3 of y squared is equals to, the other side, if you factorize out log to base 3, this addition goes back to multiplication, meaning we have 9 times x. So the moment you take log to base 3 inside, multiplication goes back to addition, the reverse process, isn't it? So if you have log single term on either side of the equation, we can now ignore that log to base 3. It is like we introduce log to base 3 on either side of the equation, isn't it? So what do we have? Y squared is equals to? We remain with y squared is equals to 9x. Are we together? So we can solve the three equations by any method, isn't it? Where there is, here we have y squared is equal to 9x is y squared, so we can use substitution. Where is y squared is equals to 9x, but y is 2x plus 1. See, we've substituted y in equation 1 in equation 2. Meaning where there is y, we put 2x plus 1 in the second equation, and y here we have, meaning it is 2x plus 1 squared, isn't it? Are we together? So if you expand 2x plus 1 squared, what do you get? You get 4x squared plus 4x plus 1 is equals to 9x. That is expanding a perfect square. You know it is a quadratic identity very fast. you know very well that when you have a plus b squared, that is a squared plus 2ab plus b squared. So you can see your a is 2x. Are you seeing that? Isn't it? See, your a is 2x. Then your b is 1. Isn't it? So 2x, you will get 4x squared. 2x if you square, you get 4x squared. Then 2ab. 2 times 2x times that, you get 4x. Then b squared, 1 squared, you get that. Isn't it? Are we together? Good. After that, see, you simplify. So bringing 9x this side, what do you have? 4x squared plus 9 plus 4x minus 9x, you get negative 5x plus 1 is equals to 0. So which numbers gives you a product of 1, the sum of negative 1? And you use factorization. A sum of negative 5 and a product 4. See, that is negative 1 and negative 1. Isn't it? Negative 1 and negative? So it means here we have 4x squared minus 4x minus x plus 1 is equals to 0, factorization method, isn't it? So we'll get here, 4x is a common factor, you remain with x minus 1. Then here we have negative 1 is a common factor, you remain with x minus is equals to 0. Negative 1 to negative 1, you go back to your positive 1. Is that okay? Good. Having done that, so it means here we have 4x minus 1 into x minus is equals to, so it is either the first factor which is 0 or the second factor which is 0. So either 4x minus 1 is 0 or x minus 1 is 0. So here we get 4x is 1 or x is 1. Are we together? So what is x here? X is 1 over 4 or x is, then what is y? Remember y, for you to get y you substitute x in either of the equation, and it is easier to use the first equation, isn't it? So when x is 1 over 4, what is y? Where there is y, where there is x, you put 1 over 4, meaning y will be 2 into x plus 1. Y is 2x plus 1. 2, but x, when x is 1 over 4, what is y? What do you get? A half. 2 times 1 over 4 is a half. Half plus 1 is 3 over. Are we together? So it means when x is 1 over 4, y is 3 over 3 over 2. Then you go to the second one. So we found y is 3 over 2. That solution is one pair, isn't it? Then when x is 1, y is what? Where there is x, you put 1. 1, you get 2 plus 1. Y is 3. Are you seeing we found the pair of solutions? Meaning when x is a quarter, y is 3 over 2. So you can say this is x1, y1, you can say this is x2, y2. Second solution, isn't it? Are we together? And you solve the simultaneous logarithmic equation.